How many ways can two identical teddy bears and 7 distinct Cabbage Patch dolls be distributed to 3 children so that each child receives 3 gifts? It says here it's possible for the 3 gifts to include both teddy bears. Now, the difficulty of this problem is that it mixes identical elements with distinct elements. The first try, so the first thought then I have is to see if we can apply the technique of a word with letters, permutating letters of a word, where some of the letters are repeated, right? So I think that's our first intuition. However, that does not work, and let's see why. So if I try to use the distinct letters, the permutation of letters where some are distinct, some are not. So let me draw here 7 spots. So let me try again. So here, 1, 2, 3, 4, 5, 6, 7, and then 2 more, right? So the total is 9. So we have 9 spots. And if we can think of the distinct patch dolls as distinct letters, and then the 2 identical, right, teddy bears would be letter T, and then the other letters, the other 7 could be A, B, C. Let's see that, A, B, C, D, E, F, G, right? And then we are permutating the letters. Now this doesn't work because it says distributed to 3 children. So let's say this is for child number 1, these 3 here for child number 2, and this is for child number 3. So when we permutate the letters, then for example, if I permutate these 2 here, T and A, right? A here and then T, so that will be a different way, different option. But for the problem, it's not a different option because this child will still have 2 teddy bears and 1 of the distinct dolls, right? So it says each child receives 3 gifts. So this child here has the same 3 gifts. So the difficulty is that it's not a permutation, it is a combination within each category, right? So these 3 elements here, they can be changed and they will stay the same. So the order doesn't matter in each one of them. So permutation of letters with repeated letters and some of the distinct letters, so that technique doesn't work. Another technique could be, that we could try, would be simply selecting, right? For each child, select 3 gifts. So maybe for the first child, out of the 9, we select 3. For the second child, out of the remaining 6, we select 3. And then for the last child, out of the remaining 3, we select 3. This doesn't work either because when we select 3 elements, some of those elements are repeated, right? I could get 2 identical teddy bears. So this technique here works only if all the elements are distinct. So it doesn't work. And the other option could be distributing the identical elements first and then distributing the other distinct elements. So I think that's the best way. And I think one thing you could try is to actually list some of those ways, right? How many ways we can do this? List some of them and see how they look like. So here's what I would do. I would list the 3 children. So child number 2 and child number 3. And then this child will have received 3 gifts. This child will receive 3 gifts. And this one too. And then, for example, I would, let's say this child has 2 teddy bears. Notice there is only 2. So that means that the other spots will be all distinct elements, right? Maybe A, B, C, D. And then another option could be that this child here will have 1, this child here will have 1, and then you distribute the rest. So you distribute the identical elements first, and then for each of those cases you can see how many ways you can distribute the distinct elements. So I would first try to distribute the identical elements. So to do that, this child could have 2 teddy bears, this child could have 2, this child could have 2. Another possibility is this child has 1 and this has 1, this one doesn't have any. Another would be 1 teddy bear here, another here, and another possibility would be 1 teddy bear here and here, right? So a total of 6. So you do the distribution of the identical elements, and that we know how to do, and we know how many they are, right? So we can look at this as a tally diagram like this, right? And the T's here would be those X's. Remember those X's that we saw when we distributed identical elements. So there will be 2 T's and 2 I's, right? In the previous examples, we used the letter X, XX, II, but this would be T, T, II, right? This same thing here, I, T, T, I, right? You have 4 letters, and you're permutating, so the number of ways will be permutating those 4 letters. So what is the total number? Total number will be 4 letters. There are 2 T's and there are 2 I's. So that is 4 times 3 times 2 times 1. This is 2 times 2. So there's a total of 6. So there's a 6 cases, 6 possibilities where you can distribute the 2 identical teddy bears. And I listed all of them here, right? 2 teddy bears here, 2 teddy bears here, and then here. Another possibility would be a teddy bear here and here, and then 1 here and 1 here, and the last one, a teddy bear for this first child and a teddy bear for the last child. Okay, now it's time to distribute the distinct elements. Now in each case, the distribution of the distinct elements will be different because, for example, I have a spot here for the first child, right? I have a little spot here, and I have 3 here, and I have 3 here, right? And then for this second case, I have 3 spots here, and then 1 spot here, and then 3 spots here. This third case, I have 3 spots here, 3 here, and then 1 spot here. This case, I have 2 spots here, 2 spots here, and 3 here. 3 spots here, 2 spots here, and 2 spots here. And then finally, 2 spots here, 3 spots here, 2 spots here. Right, so each child will have 3 gifts. Right, that's why I put a total of three elements for each child. Right, then I need to distribute the distinct elements. So let's take a look at the first case here. First case, the distinct elements, I have 7, so I could have 7 elements here, and then 6, 5, 4, right, 3, 2, and 1. Now, should I multiply all of this out? Yes, but remember that in each group, the order is not important, right? So, for example, if I put elements here for child number 3, those elements can switch, can permutate, and that will not give you a new permutation. So it is combination, right? We need to get rid, the order is not important within each group. So this would be 7, and then this would be divided by 3 factorial. This would be divided by 3 factorial. So that first possibility, first option would be 7 times 6. So I'm going to multiply the whole thing on the top, right? 7, 6, 5, 4, 3, 2, 1. That's 7 factorial divided by 3 factorial times 3 factorial. That's this first case. Look at the second case. I have 7 possibilities here, 6, 5, 4 possibilities here, 3, 2, and 1. So the second case would be also 7 factorial, and then remember, divide here by 3 factorial, here by 3 factorial. So same thing. Now look at the third case. So we did this one, now this one. 7, 6, 5, 4, 3, 2, and then 1 possibility here. Remember, this divided by 3 factorial, this divided by 3 factorial. So this would be 7 factorial divided by 3 factorial times 3 factorial. Look at the fourth case, 7, 6, 5, 4, 3, 2, 1. This would be divided by 2 factorial. Now why it's divided by 2 factorial? That's because in this group, right, for the child number 1, I have these 2 spots for distinct element. Remember, child number 1, in this case, the child number 1 has 1 teddy bear. So that child has a spot for 2 distinct dolls. So when we put the 2 distinct dolls in there, if we switch those 2 distinct dolls, it's the same, right? It doesn't change the distribution. So the order doesn't matter. But because I have 2 spots, I divide it by 2 factorial. This would be 5 times 4, right? This is 4. Also divided by 2 factorial. And this is divided by 3 factorial because it has 3 spots. So this would be 7 factorial divided by 2 factorial times 2 factorial times 3 factorial. Okay, fifth case, 7, 6, 5 divided by 3 factorial, 4, 3 divided by 2 factorial, 2, 1 divided by 2 factorial. So it will be same thing as the fourth case. 3 factorial, 2 factorial, 2 factorial. Finally, the last case, sixth case, 7, 6, 5, 4, 3, 2, 1, 2 factorial divided by 3 factorial divided by 2 factorial, 2 factorial, 3 factorial, 2 factorial, right? All right, so these are different cases. So I'm going to add this up. Okay. Now when I add this up, notice that I have 3 of the same thing. So this would be 3 times that. And I have 3 of these here. So that's the answer.